Hello, friends. Welcome to the new episode of Analytical Chemistry series. This is Chem Explain. Now, after a few weeks, 2 or 3, we are going to continue this series again. I really apologize if you're a little late, but believe me, we are back on track. So, as far as you can remember, in the previous episode, which would be episode 4, we discussed a reaction, which is here. We can see it. The number of that problem was 2.12, if I'm not mistaken. Now, let's take a look at this reaction. It says sodium carbonate plus silver nitrate gives us silver carbonate plus sodium nitrate. It's a simple reaction, but as you can remember, in this example, in this problem, the only data which is available is the mass of sodium carbonate. And the amounts and the masses which we are looking for are the amounts of silver nitrate and silver carbonate, which is going to form. On the other hand, we can find some molar masses of different species here, such as sodium carbonate, silver nitrate, and silver carbonate. All of these amounts are available in the handbooks of analytical chemistries and appendix of textbooks. Okay, so we did this example, we elaborated on this, we calculated the amounts on the paper, but from this episode on, we are going to learn some techniques and some ways to calculate the amounts using the computer and programs. The program which we specifically are going to use is Microsoft Excel. And for your knowledge, I have to say that Microsoft Excel is vastly used and it has an extensive application in analytical chemistry. And we plan to learn it during the episodes and during the seasons and chapters and series that we continue. So it would be really beneficial if you pay attention. So I think now you're familiar with the reaction, what is happening, what we are looking for, and the basic data that we have. So from now on, we move to Microsoft Excel to do the following calculations. Let's go. Okay, so here I have the reaction for you to make it easier to think about. And as you can see on the top left corner, I have the number of the example, 2.12, and in this block I have a short, let's say brief definition of the reaction, which says sodium carbonate plus silver nitrate. And we have two other sections. The first one is the quantities given. All of the numbers that we already have in the problem, or we can find using a really simple search in the appendix of the textbook. And the next, let's say, stage, the next section would be calculations. And this stage has the things, the amounts, and the masses that we are looking for. And here you can see I have R1, I have R2, I have P. You may ask, what are these? So to make it easier to work with, R1 stands for the first reactant, which is sodium carbonate. R2 stands for the second reactant, which is silver nitrate. And P stands for the product, which we are looking for. You may say that sodium nitrate is also a product, but be careful that in this problem, we are not looking for the amount of the sodium nitrate which is formed. So the only product which we aim to calculate the amount is silver carbonate. Okay, now in the first stage, I have the mass of the first reactant, which is 2.33 grams. Also, I have the molar mass, which is 106 grams per mole. Also, I have the stoichiometric ratio. Look here, we can say we have 1 mole of sodium carbonate equivalent to 2 moles of silver nitrate. So this stoichiometric ratio is unbelievably important. Do not forget this. Also, we have R2, which we don't have the, let's say, amount or the mass, so nothing is here. We have molar mass of R2, which is defined. Actually, it's 169.9 grams per mole, and we don't have the amount of the product, but we have the molar mass, which is 275.7 grams per mole. Okay, let's head to the calculations. First, we are going to work on part A, which wants the amount of the first reactant. Be careful, we have the grams, we have the mass. We want to find the amount. This is grams, this is moles. Also, we want the amount of the second reactant, which is needed. So the reaction will go. And also, we want the mass of the second reactant, which is needed. Okay, let's go and calculate all of these parts together. So we have the mass of the first reactant, and we have the molar mass of the first reactant. So by dividing this number to this number, we can find the amount. Okay, so we want to give the Excel the formula to calculate this number automatically. It means every time that we change the, let's say, input amount or input mass of the first reactant, it automatically calculates the amount of the first reactant in moles. Okay, so we want to give the formula. We say this block, which is block B15, equals this block, which is the mass of the first reactant, divided by this block, which is the molar mass. And we hit enter. So we simply have the number of moles of the first reactant here. Now, let's go to the second one. So we have in mind that the stoichiometric ratio of the reactants is 2. It means each mole of sodium carbonate needs 2 moles of silver nitrate. So to find the amount of the second reactant which is needed, we need to multiply this number, I mean the moles of the first reactant, by 2. So we don't do it on hand. Again, we want to give the formula. So we say this block equals this number times 2. You can say times 2, or simply you can say times the stoichiometric ratio. And we hit enter. So the amount of the second reactant is also calculated. Now, we need to find the mass. It's really simple. We have the moles, we have the molar mass, and by multiplying them, we can find the grams. So this block equals the moles of the second reactant times the molar mass of the second reactant. Simple as that. We hit enter, and finally we have the grams of the second reactant. Okay, let's head to part B. In part B, we need to find the amount and the mass of product, which is silver carbonate. So the amount of silver carbonate, I mean the moles of silver carbonate, is exactly equivalent to the sodium carbonate. You may ask why? Because they have the similar stoichiometric ratio. I mean, both of their coefficients are 1. So here we can say that the amount is exactly similar to the amount of the first reactant. So this block equals this block, and we hit enter. Now we need to find the mass of this species, okay? So we can say that this block equals the moles of the product times the molar mass of the product which we're looking for. And we hit enter. So as you can see, the numbers in these parts are automatically calculated. To show that this process happens automatically, we can change the initial input mass of the first reactant. So we can see that the outputs or the amounts or masses that we are looking for will also change. So the example says 2.33 grams. We want to change it. As an example, I want to change it to 4.66 grams. As you can see, all of these numbers change simultaneously, and the new amounts of masses are calculated in a glance of eye. Thank you so much. This was today's video. Hope you enjoyed it. Have a great day, and bye.